We're face to face with one of the most mysterious and fascinating entities in the universe, black holes. They don't just push the boundaries of scientists, but also our imagination. They're the universe's biggest mystery boxes. Black holes are so strange, so incredible, that just trying to understand them is an adventure in itself. Today, we're chasing after these cosmic giants, discovering how they form, what they do, and why they're so captivating. If you're ready, let's embark on a journey to the darkest corners of the universe. Imagine looking up at the night sky and seeing among the stars a region that emits no light at all, a spot of pure darkness. It's as if the universe itself has poked a hole there. That's exactly the feeling black holes give us. They're invisible giants hiding in the deepest, darkest parts of space. But even though they're invisible, they affect everything around them, sometimes even determining the fate of entire galaxies. They're cosmic powerhouses, shaping the universe in ways we're only beginning to understand. It all started in 1915, when Einstein said, "Space and time aren't as fixed as we think." Until then, everyone thought of space and time as a kind of stage we walk on. But Einstein said, no, space-time is like a fabric, and massive objects bend this fabric. Imagine putting a heavy bowling ball on a trampoline. The dip it creates is gravity. This idea shook the world of science like an earthquake. Until then, Newton's "the apple falls because the earth pulls it" was the rule. But suddenly, gravity had a whole new meaning. But the real bombshell came when German physicist Karl Schwarzschild solved Einstein's equations. Even in the middle of war, Schwarzschild never stopped doing science. He said, if you squeeze enough mass into a tiny point, space-time bends infinitely. What emerged was unlike anything we'd ever known, a point of infinite density, a singularity, and around it, a boundary called the event horizon, a point of no return. Nothing, not even light, can escape once it crosses that line. It's like the universe's secret passage. The event horizon is the universe's one-way door. Whatever goes in never comes out. The funny thing is, even Einstein didn't want to believe this idea for a long time. Nature wouldn't allow something so extreme, he said. But over time, observations, mathematical calculations, and signals from the depths of space proved that black holes really do exist. In 1967, John Wheeler gave them the name black hole, and from that day on, these mysterious entities captured the imagination of both scientists and the public. Black holes became a phenomenon in popular culture too. Think of the massive black hole gargantua in the movie Interstellar, which fired up the imagination of millions. So how is a black hole born? The story begins when a massive star reaches the end of its life. When it runs out of fuel, fusion stops, and the star can no longer resist gravity. Then, bam! The star collapses inward under its own weight. The outer layers are blasted into space, while the core shrinks and shrinks until it reaches infinite density. At that moment, a black hole is born. It's like the universe's greatest magician makes a giant star disappear and leaves behind an invisible monster. This happens alongside a supernova, the biggest explosion in space. The supernova blasts the star's outer layers away while the core becomes a black hole. When a black hole forms, it creates a gravitational field so strong that even light can't escape. Anything that gets close, star, gas cloud, spaceship, gets pulled in, never to return. Imagine a place in space where nothing, not even light, can ever escape. That's why black holes are invisible. But don't think they're hiding completely. As they swallow and heat up matter around them, they emit such powerful radiation that it's like they're shouting, "I'm here." The gas and dust swirling around a black hole form a giant ring called an accretion disk. This disk can heat up to millions of degrees and emit X-rays, gamma rays, and other energetic radiation. Some black holes can even outshine their entire galaxy. Sometimes, by pulling matter from nearby stars, they create quasars, the brightest beacons in the universe. Quasars are so bright we can see them from billions of light years away. So black holes aren't just destroyers, they're also the universe's greatest energy sources. These accretion disks around black holes work like cosmic ovens. Matter falling in accelerates and heats up so much that the energy released can overshadow an entire galaxy. Some black holes even shoot out gigantic jets of energy from their poles, traveling at nearly the speed of light and stretching across thousands of light years. In other words, black holes don't just swallow, they also pump energy into the universe, like cosmic engines. Now, let's get to the most exciting part. What happens if a person falls into a black hole? Scientists call this spaghettification. Yes, you heard that right. If you fall in feet first, the gravitational pull on your feet is much stronger than on your head. The result? Your body stretches, thins, and eventually gets torn apart down to your atoms. But to an outside observer, you'd appear frozen at the event horizon. That's because time slows down so much near a black hole, it almost stops. For someone falling in, only a few seconds might pass, while for someone watching from afar, thousands of years could go by. This is one of the wildest examples of time's relativity. Near a black hole, time stretches and bends like a rubber band. But wait, there's more. The universe doesn't just have small black holes. There are also gigantic, supermassive black holes at the centers of galaxies. These monsters have the mass of millions or even billions of suns. For example, at the center of our Milky Way is a supermassive black hole called SagittariusA star with a mass of 4.3 million suns. Scientists think galaxies themselves form and dance around these giants. How these supermassive black holes form is still a mystery. Do they merge by smaller black holes, or did they appear in the early universe? The answer could unlock the history of the cosmos. And in 2019, one of the coolest photos in human history was taken. The Event Horizon Telescope captured the shadow of a supermassive black hole at the center of the M87 galaxy. That orange-black ring wasn't just a photo. It was proof that humanity had taken a step closer to the universe's secrets. It showed just how real and mind-blowing black holes are, and how space-time can be warped. But there are still so many unanswered questions. For example, does information that falls into a black hole really disappear forever? According to Stephen Hawking's Hawking radiation theory, black holes can slowly lose energy and evaporate over time. So they don't live forever, but where does the information go? Quantum physics says information can never be lost. Classical physics says information that falls into a black hole is gone forever. This contradiction is one of the biggest mysteries in physics. The information paradox keeps scientists up at night. If information is really lost, the fundamental laws of the universe are called into question. And of course, there are some mind-blowing theories out there. Some suggest black holes could be gateways to other universes. Could matter that falls into a black hole emerge from a white hole in another universe? Who knows? We don't have any solid evidence yet, but even these ideas show just how fascinating black holes are. Maybe black holes are the key to interuniversal travel. Maybe one day we'll find a way to pass through a black hole and reach another universe. In the end, black holes aren't just destroyers, devourers, or dark monsters. They're also the most creative, energetic, and inspiring players in the universe. Maybe the key to unlocking the universe's secrets is hidden inside them. And we humans, chasing this great cosmic puzzle, are getting a little closer every day. Who knows, maybe one day we'll pull back the curtain on the mysteries behind black holes. Until then, black holes will keep reminding us just how astonishing, mysterious, and awe-inspiring the universe truly is. And remember, even in the darkest corners of the universe, there's always a light to discover, a secret to unravel. Black holes make us feel both fear and curiosity at the same time. Maybe that's why we never stop trying to understand them, because every black hole is a riddle whispered by the universe itself. And we'll keep chasing that riddle, no matter what.
Black holes push the boundaries not only of the universe, but also of our minds. Perhaps one day, beyond those dark regions where even light cannot escape, we will discover the universe's deepest secrets. See you in the next video. Goodbye.
The Door to Knowledge, presented by Toyer TV. Don't forget to take your place on this path of discovery and enlightenment.